Okay, so now that we've done a little bit of work on piecewise function, we're going to use them to introduce a new notation. So we're going to consider our parking garage problem from the last lesson, and we're going to look at the point x equals 3, which is here, right? X equals 3. So now that we have these functions that come in multiple pieces, it might be useful for us to have a way to talk about how if I'm standing to the right of x equals 3 and walking along my line, I end up at one spot, right? But down here, if I'm standing to the left and I'm on the other piece, I end up at a different spot, right? So really, we're adding this notion of direction. From which direction are we coming? And that allows us to describe these functions in a little bit more detail. So this idea is the idea of a limit. And this idea really underlies all of calculus, so all of what we'll be doing next year. Right now, we're not going to make this idea super deep or complicated. We're really just worried about how we write these down. So it's a new notation. The notation looks scary, but the idea is not that hard. So we're really just going to focus on writing the notation correctly here. Okay, so let's introduce this idea. It's a very simple idea. So as x approaches 3 from the left, that is a value smaller than 3. So that's, imagine we're standing over here on the function walking towards my point x equals 3. My y values approach 8, right? So we're really talking about we're walking towards this point here. And what that means in context is if I'm parking for a little bit less than 3 hours, as I get close to 3 hours from that direction, my price is approaching 8. And then I'm going to switch colors for this, and we're going to consider the other side. So from the right, well, that's from a value greater than 3, so 3 hours or more. My y values are approaching 10. Okay, so that's not a hard idea to see. So imagine if you were standing on this function. If I were standing here, right, and walking towards x equals 3, I would end up at one spot. I would end up at 10. Whereas if I were standing on this little piece down here, walking that same, not the same direction, but towards the same value, I would end up at a different spot down here. That's all we're saying here. So not a super complicated idea, but we're going to make sure we can write this idea down like a mathematician. Now, the way we're going to write this down in our new notation, our limit notation, is I'm going to say the limit as x approaches 3, and here we need a direction, right? So the way we're going to say it from the left is the left is smaller than 3. It's the negative direction, right? So I'm going to put a little minus behind the 3. That doesn't mean negative 3. It means to the left of 3. So the limit as x approaches 3 of f of x is equal to 8. That's all I say. So this means the same thing as what we just wrote over here. It's just writing it in this new notation. This notation makes us look smart because it looks complicated. Now, from the right is the positive direction. So I'm going to say the same thing. The limit as x approaches 3 from the right of f of x is equal to 10. So that is limit notation. That's how we describe this function. And that gives us a way to write down quickly which value the function approaches and from which direction. Now, it's important for you to be able to say these things out loud. So what I want you to do is write down in words how to say this. And if you're even somewhere where it wouldn't be awkward to do so, like say it out loud. So the limit as x approaches 3 from the right of f of x is 10, is how you say that. So the limit is really just the limit as x approaches 3 is this part. From the right, well, is the plus, and then f of x is what we're talking about, is our equal sign, 10 is the value. So again, say that out loud, read that out loud, and try to connect those pieces in your mind if you're in a place where you can do that. So now we're going to introduce a definition to go with this notation. This again is not that hard, but it looks harder than it is. So we're going to consider this second graph, and we're going to consider this point x equals 2 first, right? So x equals 2 is here. And notice that my function is not continuous at that point. It has a little hole there. This dot does not matter at all. We don't care about that. We just care about what we get close to as we walk towards 2 along the function. So for this function, again, we have this graph called f. So I'm going to say the limit of f of x as x approaches 2, we'll do from the left first. I'm going to say it is equal to, I'm going to say it's equal to negative 2. Because from the left-hand side, as I walk towards that point along the curve, my y value ends up being negative 2. And notice that is also true from the right. Same thing, right? So I'm going to say the limit as x approaches 2 from the right of f of x is equal to, again, negative 2. So those two limits are the same, right? So I'd say the left and the right limits are equal to each other. Now, when I look at negative 3, that is not the case, right? So same thing, the limit as x approaches negative 3 from the left-hand side of f of x, well, we go down forever at that point. So it is negative infinity. And then from the other side, notice I'm going now in the opposite direction. So as I approach negative 3 from the right, I'm going to positive infinity. So these are not the same. Okay? So we are also going to have a way now to talk about whether the values approach the same thing from either direction. So my two-sided limit for x equals 2, I can just write the limit as x approaches 2, and notice I have no positive or negative here, from f of x is negative 2. So I don't have to specify here the direction because my limits are the same on both sides. However, if I wanted to do that at negative 3, and again, no plus or minus here, I would say this limit does not exist. And that's because the left and right limits are not the same. So it doesn't make sense to talk about in general which direction does the function approach, because it's different depending on where I'm standing. If I'm standing over here, I end up at one spot. If I'm standing over here, I end up at a different spot. So capture this idea now, this idea of the two-sided limit. So this two-sided limit only makes sense if the limits are the same on both sides. So that's at x equals 2, yes. At x equals negative 3, no. Two-sided limit does not exist. And again, my notation looks complicated here, but it's really not that complicated an idea. Can I walk along the function and end up at the same spot every time? Or is where I end up different depending on the direction that I'm coming from? Okay, one last thing here, and that's the table. And this is easy. So notice my x values get closer and closer to 3, right? Because 2.9 is pretty close to 3, but 2.99999 is very close to 3. And my y values, well, they look like they get closer to negative 2. So I can write that down, right, by saying the limit as x approaches 3 of f of x again is equal to negative 2. So notice here's my x, here's my y. And I need a direction. So the direction is maybe the trickier part. My direction is negative because if I draw a number line here, 3 is here, 2.9 is here, and 2.99 is here, kind of thing. Okay, so I'm approaching from the left-hand side, the negative side. So again, not that complicated of an idea here. Same idea as the graph, we can just represent that same idea in a table as well.